Hello, this is my video for my engineering project, which was space related, not necessarily the Artemis project, but it's my um, human centrifuge. So this model is just to show the basic idea of the forces enacted on an astronaut as they use this exercise machine. So, and I'll show you some of my other parts that didn't print out as well. And yeah, okay. So we can go down here, check this out. So I'm going to take this out of here. This is like an eraser head, and this is all I could find that would roll in here that was small enough. But so as we can see, I can spin this and it goes pretty smooth. I know, extremely impressive. This was much harder than what you think, what you may think it is. I mean, it's pretty simple, but so okay, we got three parts here, right? I already explained them, but we have this part goes over the center here, right? This piece, which normally I would use for a drill, but for some reason I can't find a bit for the drill that'll work, so I guess I'm just spinning it by hand for now. And the gear. So the gear is really cool. So this is my previous gear. Huge, humongous, big chungus, twice as big as it needed to be. You can see that kind of. Well, this one has more teeth, so you know, if this one were to have 6 teeth, it would be twice as big as this one. But okay, so this one had 4 teeth, was twice as big as I should have made it because I'm dumb, and yeah, does not fit, does not even close. So it was a shame. So, and then we can see here, it still has the supports on it. It was really hard to take the supports off. So, but this is basically this, just way too big. And so I was a moron for doing that. But now we have them in different colors, and they work better. And so I put like grease, a little, just like a tiny bit on this part right here, so that when it's spinning, it spins really well. And then you can see here, this doesn't quite line up, but then you just gotta like push it to make it line up, and there's a little tolerance in there. And so basically, right, spins around really well. And then, so let's say this is our astronaut. We'll put it right here. So if we spin it really slowly, nothing's gonna happen, right? So, oh, I should explain this. In here, it's at a slope. You can see that, right? This is sloped. So this is the bottom of the slope, and this is the top of the slope. So that when this is in resting position, oops, when it's in resting position, it goes to the bottom. So, and it's a little bumpy, so it doesn't work perfectly, but basically, if I were to go super fast, like spin it like this, well, since it's bumpy, it like doesn't roll back down, but you see it move to the front, right? So let me like wiggle it back. Okay. Then we do, oh crap, fell out. You know, as it's spinning, it's moving forward, right? And it would work better if I had a ball, but, right? So what's important though is that each time I'm spinning it, it's always ending up at the front, right? And why is that? And so it's because the forces of this centrifuge, right, are pushing the astronaut outwards. So now imagine this. Imagine that it's like this and it's in space. Well, it doesn't really matter because in space there's not really any direction. So imagine how it's any direction. And So I'll just put it like this so it's easier to understand. So you have an astronaut here, or like this, and he's sitting like this. This is his head and this is his butt, and he's facing, he's facing like this way, and he's pedaling it around and around and around, and gradually accelerating faster and faster. And what happens is the astronaut is moved to the outside. He's pulled to the outside, right? Like centrifugal force. And it's as he's accelerating, it would have to be, or as the astronaut is accelerating, it would be pulling them out, and it would create like an artificial gravity type thing. But what I'm guessing is that would only work as long as they're accelerating, because if you can imagine, if you're in space, when you're in space and you're on a spaceship that's orbiting Earth, you're not constantly, pushed up against the back of your seat because you're orbiting Earth at 1,000 miles an hour, right? You're going at the same speed as, the rest of the ship. So, if you imagine the rocket going up, right? The initial acceleration has the astronauts pushed into their seat, but once it stops accelerating, then everything's good. Okay? So it's the same concept. Presumably, you would have to have the astronaut continually accelerating for this to work. But technically, I mean, this form of exercise might just work better anyways, and it might just be worth it for the astronauts to, be able to like shift through gears, spin super fast, and then have them slow back down and restart it, and and then go again with the acceleration process, and that could definitely give them better exercise in space. So that's my explanation. That was my wonderful thing. Here's my incompleted prints that were very disappointing, which I should have kind of understood what was happening, but so these only like printed like half an inch. I don't know what I'm gonna do with this. I guess it's a coaster now, but yeah, pretty cool. Anyways, I'm very proud of this. You'll notice the shape of the gears. Instead of being round, as I had them before, they are now, I took a cut of the edge. So they were round, but then I just cut the edge of each one, and I kind of mirrored that cut for each one, and now they're kind of like that shape, and it looks like a snowflake almost. So yes, that is my presentation.